So today we're looking at 12.4a, which is geometric sequences, and they are similar to an arithmetic sequence except for instead of adding and subtracting, we would be multiplying. So definition of geometric sequence is where we have a ratio instead of a common difference. So if you look at our example here, we're multiplying each of the previous terms by 3, so our common ratio would be 3. The explicit formula then, you take the first term multiplied by the common ratio to the n minus 1 power. So again, n is the number of the term you're looking for. And then last we have the recursive formula, which again, similar to the recursive formula for arithmetic, except for instead of adding or subtracting that common difference, we're going to be multiplying by that common ratio. Okay, so first we're going to take a look at, given a sequence, first we need to find the common ratio. So the way we do that is we take the second term and divide by the first term. And this gives us, if you use your calculator, you'd get 0.4, which is 4/10 or 2/5. And so just to check to make sure that it's a geometric sequence, we can take the third term and divide by the second term. We get that same common ratio, it simplifies to 4/10 or 2/5. And then take the fourth term and divide by the third term. And again, when we simplify this, we get 2/5. So that common ratio between all of our terms is the same. And of course, our first term is 250. So then we substitute into the explicit formula, which is t sub n equals t sub 1 times r to the n minus 1 power. So our first term is 250. Our common ratio is 2/5 to the n minus 1 power. And then the last piece is to solve for the fifth term. So t sub 5 equals 250 times 2/5 to the 5 minus 1 or fourth power. And that gives us 6.4. Second example, our first job is to determine whether or not the sequence is geometric. So similar to what we did on our first example, we have to find the common ratio between all of our terms. On this one, hopefully you guys can see 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So yes, this is a geometric sequence because that common ratio is constant. So to find the next three terms, we keep multiplying by 2. 32 times 2 is 64, times 2 is 128, times 2 is 256. I think I was thinking powers. All right. Similar, determine if the sequence is geometric. So as I look, I'm multiplying by 2, but then I'm multiplying by 3 and multiplying by 4. That common ratio is not consistent, so it is not a geometric sequence. However, there's definitely a pattern, so we can find the next three terms. I would take 48, multiply by 5, and get 240. Multiply that by 6, get 1440. And then multiply that by 7 to get 10,080. So now we're going to use the explicit formula to list 4 terms of a geometric sequence. So term 1 would be substituting 1 in. So 4 times 2 gives us 8. Term 2, we would substitute 2 for n. 4 times 4 is 16. Term 3, substitute 3. 4 times 8 is 32. And then term 4, 2 to the 4th is 16 times 4 is 64. And this is our last example. It's the first 4 terms given the recursive formula. So this time I see my first term is 18. And what the recursive formula tells me to do is take -2 times the previous term. So that t sub n minus 1 is the term right before it. So term 2 would be -2 times our previous term, which gives us -9. Sorry, I divided by 2. My math is a little off today. So we're gonna get negative 36 instead. All right, term 3, we multiply by negative 2 again from our previous term. So we get a positive 72. And term 4, we would multiply our previous term by negative 2 and get negative 144.